Lesson 67, 68, yes, you'll notice right off the bat we're seeing something called anti-log. It's really not as hard as it looks. So even if you look in the book on this type of thing, essentially what you're doing on this is you're taking the base and the number and you're moving everything up and dropping off the log portion altogether. So really what you're doing when you're doing anti-log base 5, 5 is you're taking 5 to the 5th. That's it. Right? So if we get down to number 2, right, what we're doing is we're doing 6 to the negative 5th. Does that make sense? So there, and it's not to say that it's overly simplified, because we've seen questions where it was a number that was had an exponent, right, where log was in the exponent, and sometimes we forget what to do with that. Right? But here, like anti-log base 5, 5, that's going to be 125, or sorry, 3,125. Right, and you check that with your calculator. But there's not an actual calculator function that's going to do that for you. It's not like there's an anti-log button in your calculator, at least not that I'm aware of. Now, granted, there is a lot of stuff in your graphing calculators that I've not used and not played with. So if there is, let me know. But to my knowledge, there's not. So anyway, okay. All right. And so what you guys are going to do is you're going to pull out that calculator and solve anti-log 6, negative 5. Tell me what you get. I apologize for the awkward silence on this recording while people are diligently getting out their calculators, punching in those keys. Tap, tap, taparoo.
Need to whisper it so it's like it's math ASMR.
Tap.
Now I'm going to demonstrate my ass on the calculator.
Clickety clack. All right, did we get an answer yet? Should not have taken this long. Like 6, caret symbol, negative 5. What did you get, Haley? B. B is correct. 0.000129.
6 6 negative 5.
6 to the negative 5th.
I think I got the same thing Dylan got. I got 1.2.
I got 1.2. I got that too, but I just put a bunch of zeros in it and called it good.
What?
We don't get the 0.
Is it putting it in scientific notation for you?
Yeah.
All right, so it's basically saying 1.29 times 10 to the, or is it giving you an E answer?
Yeah, E.
Yeah. So you have to go ahead and put in those zeros. Okay, so it's giving you your answer in scientific notation, which is still B. Okay. So that is, as far as I can see, all that lesson 67 is that, those 2 questions. All right. The rest of this is lesson 68. Lesson 68 is locus definition of a parabola, translated parabolas, applications in derivation. So it's going to be fun. Okay. Oh, it's good stuff. So it says find the equation of a parabola with its vertex at the origin if its directrix is x equals negative 3. So I'm going to try to define this for you. You're going to hold on to this. Hopefully, did everybody get this document? We're looking at it. Okay.
Oh, we're not looking.
Oh, okay. Okay. So what it says here, with this directrix, x equals negative 3, what kind of line is x equals negative 3? Vertical line. Okay? So, all right, we're going to see our directrix line looks like this. Okay, that's my directrix. So what I want you to know about a parabola in relation to its directrix, it's always going to open away from the directrix. Okay? So if my directrix is a horizontal line, then that means that my parabola is either going to open up or down. Okay? If my directrix is a vertical line, then my parabola is either going to open left or right based upon where that directrix is. Okay? Now they did say that the vertex of my parabola was the origin, right? So if I use this, okay, I've got that right there. And so we always open away from the directrix. Okay, it never opens into the directrix. Okay, you follow me there? So am I going to be opening to the left or to the right? All right, I'm going to open up to the right. Okay, so that's what that parabola would look like. Okay? Now, but what the question is actually asking for is what is the equation? So there are some definitions that need to be read in here. You need to be turned over to page 430, more particularly 431. All right, we're going to look at, well, for now, we'll just need those for the most part. Okay? We're actually going to do a little bit of reading. All right, so make your way on page 430. You're going to see two sets of parabolas. You're going to see three towards the top, three towards kind of the middle. Directly below that second set, it's going to say, we remember that a line is the locus of all points in a plane that are equidistant from two designated points. As we show on the left, every point on the line shown is the same distance from points A and B. All right, so I put a little star on page 431 next to what you see the locus definition of a parabola is. A parabola is the locus of all points that are equidistant from a given point called the focus and a given line called the directrix. So what you're going to see with this is we see our directrix, right? Now, our focus is going to be a point that is the same distance from the vertex, but on the opposite side as our directrix. So my focus point is right here. Okay? Because my directrix is 3 away from the vertex, right? My focus is going to be 3 away in the opposite direction. So my focus coordinate is 3, 0. Okay? Because they're going to end up asking for a few different things with these questions. They're going to ask, what is the equation of the directrix? What's the equation of the parabola? What is the location of the focus? Usually that will require, they'll give you usually one thing and ask for 2 other things. Okay, does that make sense? All right. All right. So from there underneath that, under a couple of lines, is an equation that says y equals 1 over 4p x squared. Okay, we're going to need that. Okay? All right. Let's see. Then let's go on down a little bit. We're going to find another box. It says the graph of the quadratic y equals ax squared is a parabola whose vertex is 0, 0. Okay, which is true for ours as well, right? Our vertex is 0, 0, whose focus is 0p. So we have that same type of situation, so we're going to notice that ours here is 3, 0. Okay, and the directrix y equals negative p has the equation, so y equals 1 over 4px squared. Directly below that, you'll see something else. In the problem sets, we may be given only 2 of the 3 pieces of information cited in the box: vertex, focus, and directrix. So there's 3 parts to each of these. So if we can use the locus definition of a parabola to find the missing piece of information, for example, if we're given that the focus of a parabola is 0, 3, okay, and that the vertex is the origin, we can deduce, using the graphs of the parabolas drawn above, that the parabola opens up and the directrix is y equals negative 3. We were given a different set of information, so we don't necessarily use the same parts. Okay? All right, let's see if I can help us make sense of some of this. Okay? we're actually going to start off with, because ours opens sideways, is we're going to start ours off with x equals, you all right? Okay.
Oh, I thought you were coming up to hit me. I was like,
I thought she was going home. Okay, we're going to start off with this. And because our focus is 3, 0, my x in this case is 3. So I have 3x. Okay, so we plug in 3 with our x position.
you know what scares me?
What's that?
This is going to be on the test in the future.
Eventually, it won't be for a couple of tests probably. Okay? Okay? And in the end, what this ends up running into is we get a final answer of x equals. See, I really think that maybe I'm going to kind of take this back to the drawing board here a little bit, because that p is ultimately the distance from our vertex to our focus, right? So even if we kind of come back here, even though we're working with this, what we should get is 1/12, because we're taking 4 times p, or really 4 times 3, y squared, and that is our final answer. Okay, so some of these will look a little bit better the more of them that we do. Okay. All right. With that, let's scoot over to our other question. It says, find the equation of the parabola with its vertex at the origin if its directrix is y equals 5. Y equals 5. Okay. All right. What kind of line is y equals 5? What's that? Horizontal. All right. Horizontal, and it should be above the origin, right? Okay. So 1, 2, 3, 4, 5. Okay. Here is my directrix. Okay. My vertex of my parabola is at the origin. Okay. Which direction is the parabola going to open? Down. Okay. So it should look something like this, right? What would be the coordinates for the focus? 0, -5. All right, so the handy thing about this, it's opening downward, so we are getting y equals -1 over 4p. What is the distance from our vertex to our focus? In this case, we'll actually kind of use, we'll end up using that, well, yeah, it's got a distance of 5, so we'll just use 5, right? And then x squared, so we'll reduce that, y equals -1 over 20, x squared. That's it. Okay? Got it?
So the answer is
Yep. All right, our next question down. Number 5, a parabola has its vertex at 1, -3, has its focus at 1, 3. We want to write the equation of the parabola, the directrix, and the axis of symmetry. The axis of symmetry is the line that's going to cut through that vertex. Okay? So we'll start off again with what we have. Okay? Let's see. We have a vertex at 1, -3. So okay, 1, -3 should be about there, correct? Okay. We don't know which way it opens yet because we don't have enough information at this point. Okay. its focus is at 1, 3. Okay, focus is at 1, 3. Okay. All right. That should now tell me which direction that parabola is going to open. Can anybody tell me which way it's going to open? Up. Good. All right. The bits of information that they wanted out of this, it says write the equation of the parabola, write the equation of the directrix, and we wanted the axis of symmetry. Right? The rest of this is pretty easy. Okay. All right. So our equation, what we're going to use in order to find our equation of our parabola is this equation right here. Y minus k equals 1 over 4p x minus h squared. Right? There should be some familiar things about this. Right? It should look like the vertex form of an equation matched up a little bit with point slope form. Right? And kind of throw in some equation of a circle with it. Right? All right, so what you're actually using here is you're using the vertex in this. Okay? So our vertex, let's get our equation for our vertex out here again. It was 1, negative 3. Okay? Well, remember, x is h, y is k. Right? I don't know if I missed what you were saying there, but so we should have y what? Y plus 3 equals 1 over 4 times the distance between my vertex and my focus. So what's the distance between my vertex and my focus? 6. Okay. Let me make sure. Okay. All right, so we've got 6. All right, then we've got x, all right, minus what? Minus 1 squared. All right, so we'll solve out what we can do. We should get 1 over, what, 24? Times x minus 1 squared. And finally, we're going to move that 3 over. So our equation becomes y equals 1 over 24 x minus 1 squared minus 3. And by looking at this, you can see how it's using the vertex form, because the vertex form here, this is going to tell me I'm going to go to the right 1. This is going to tell me I'm going to go down 3 to get my vertex based upon the equation of the parabola. This tells me how wide it's opening, that 1 over 24. Because remember, this point should be equidistant around there. Granted, I'm not going to be exact with how I draw my parabola, but that's what we're going to get out of it. Okay? All right, so this part right here we're done with. We got the equation of the parabola. What else did we need? The equation of the directrix, right? All right, so first thing you want to see is we are 6 away this way from our focus, correct? So in order to get my directrix, what am I going to have to do for my vertex? 6 down. So 1, 2, 3, 4, 5, 6. Now what kind of line is that going to be? Is it going to be horizontal or vertical? Horizontal. And it should come across like this. So my directrix is, yeah, but how do I write the equation of a horizontal line? Is it x equals or y equals? Y equals, and in this case, what is it? Negative 9. Okay? The last part that I need is I need the axis of symmetry. The axis of symmetry should always be perpendicular to the directrix. So if it's a horizontal line, if my directrix is a horizontal line, then my line of symmetry is going to be vertical. And I write off vertical lines as what? X equals. And so I'm going to know this because it's going to cut right through there. So all I need is it needs to be x equals whatever the x coordinate is. So in this case, x equals 1 is my line of symmetry, or axis of symmetry. Okay, so we've got our 3 marks there. Does that make sense? Hopefully, a little bit. Okay. All right, number 6. Parabola has y equals 3 for its directrix, has a focus at 0, -3. We want to find the coordinates of the vertex and write the equation of the parabola. All right, start off with what we know. Okay. We have y equals 3. Again, what kind of line is that? Horizontal. So 1, 2, 3, 4, 5, 6, 7, 8. Just all of this is easier to do on a graph paper than it is to, obviously my tick marks are a terrible mess, but it's just meant to give you an idea. Okay, so y equals 3 is this guy right here. Okay, that's what they've given us. All right, let's see, y equals 3 for its directrix. Our focus is at 0, -3. Okay, 0, 1, 2, 3. Okay. How could I find the coordinates of the vertex? The same distance. So basically what we want to do is we want to find a distance from the focus to the directrix and divide it by 2, right? Right, because that vertex should be half the distance. So 1, 2, 3, 4, 5, 6, so should be half that distance, so it should be 3, which in our case shows up at the origin, right? So in terms of things where we would say vertex is 0, 0. Is that correct?
Yeah. So the vertex
Directrix.
direction, is the distance from the vertex and
Directrix.
directrix with the vertex is the same as half of the distance of the vertex to the
The distance from the directrix to the vertex is the same as from the vertex to the focus.
Wait, try again.
The distance, yeah, what,
The word. The word.
I don't know.
I believe you said dirtex.
Is that Durtex and the
Dirtex. Yes,
Director.
the battery question.
Direct.
And
I would say Milton Pond, she's there.
Yeah,
Let's make it sound like an actual name.
I was waiting for Derek Tex. So, all right, so we got one part of this. We got our vertex, which is at 0, 0. All right, what else do we need out of this? Find the coordinates of the vertex, write the equation of the parabola. All right, so easy enough. If I get into my notes here, what else? So let's start off with that full equation. That y minus k equals 1 over 4 p x minus h squared. And if you work with that, I think that's going to make a lot more sense to you. Our h and our k's are 0 here, right? So we're dealing with y minus 0 equals 1 over 4. What's the distance from our, okay, we got a distance of 3. Okay, and because we're opening downwards, we're going to do negative. And I don't know that we did that on our other one. Let's see, on 5. On 5, it opened upward, so it was positive. Okay, and this one opens downward, so it's going to end up being negative. All right. And then we have x minus 0 squared. So that's going to end up simplifying to y equals 1 over negative 12 x squared. Okay, so at the origin, that's how it ends up simplifying to y equals 1 over 4p x squared, because we're dealing with zeros. But I want you to see how that works and why it works. Okay? What else do we need out of that? Was that it? Coordinates of the vertex, equation of the parabola. We've got vertex, we've got equation, we're done with that, right? Okay. All right, let's see if we can get another one in before we run out of time. Number 7 says parabola has a vertex at -2, -5. It's got a focus at -2, 5. Write the equation of the parabola. What was that, Dylan?
The dirtex.
The dirtex. Okay.
Wait, did I get it right?
No, not at all.
God.
Direct Rix. Direct Rix.
Correct.
Okay. All right, and the axis of symmetry. All right. Let's see. We'll get this. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Okay. Let's go ahead and plot what we have. -2, -5. Right there. Okay. That's our vertex. Our focus is at -2, 5. All right. That may complicate this a little bit. Because what we're noticing is that distance between our vertex and our focus is pretty large, right, distance-wise? But which direction are we opening up here? On 7. We're opening up because my blue point is my vertex, so we're opening upwards. Okay, like that. All right. Let's see, what are we asking for? Hey guys, are we paying attention? Okay. All right, so let's start off with our equation. What was our equation? Y minus K equals 1 over 4P. Because we're opening upwards, this should end up being positive, correct? X minus H squared. All right? What coordinates do I use in this? Do I use the focus coordinates or the vertex coordinates? Vertex, so -2, -5. So we should have y plus 5 equals 1 over 4 times the distance from our vertex to our focus. What's the distance from our vertex to our focus? 10. X plus 2. So we got y plus 5 equals 1 over 40. X plus 2 squared. Subtract 5, so we should get y equals 1 over 40. X plus 2 squared minus 5. Right, the better you get at this, you should be able to write a bunch of that equation without really needing to go through all of that because you'll understand how it works. So if we would know that we're going to go plus 2, we know that we're going to go down 5, so we just plug it in. We know that our distance is 10, so we multiply by 4. So we should get all of that. All right, where are we at? So that's that. Our directrix is going to be a horizontal line, correct? And it's going to be, what, 10 below?
Yeah.
All right, so should be y equals -15, right? And our axis of symmetry should be a vertical line using our x coordinate, correct? -2. Okay? Does that help? We know what's going on there. All right, next time we'll pick it up with questions 8 and 9. We'll finish out, and you guys will have the rest of the class period to finish working either on this assignment or on your reviews, which are due on Monday, correct? Whatever it takes.